We are having another very vibrant young engineer with us. So let me introduce Engineer Tatsara Nanakara to the audience and give the opportunity for him to share his knowledge and experience. So Engineer Tatsara Nanakara graduated with a BSc in Engineering, in Electrical and Electronic Engineering from General Sobur Katalal Defense University. He's a registered chartered engineer in the Institution Engineering Council UK, specializing in electronics. He is currently working as a postgraduate research assistant at the Future Medical Healthcare Research Lab at South Korea and pursuing a master's in Industry 4.0 Bionics Engineering. So it's very pleased to have you today, Engineer Tatsara Nanakara. So we are very excited to hear from you. Over to you.
Thank you, Engineer Dushanta. I hope you can see my presentation.
Yeah, we can see your presentation perfectly.
I'm Tatsara Nanakara. Thank you for the opportunity to present this topic in Electrical, Electronic, Telecommunication Sectional Committee. So my topic is to the computer vision's application in the digital healthcare. So imagine if the computers could see and understand the real world. So just like a human. So whereas the machines or the computers can look into the X-rays, MRIs, CT scans, and if the computers can tell what is the wrong, what is the disease, so these are very much beneficial. So this is happening right now. So this is not a science fiction. Thanks for the combination of artificial intelligence and the computer visions. So today I'm excited to share these technologies to how effective this future healthcare sector. So this is my overview. So I'm going to explain the basic background, then computer vision techniques related to the healthcare, then the computer vision applications in healthcare, then finally the healthcare research areas. So this is the somewhat vast area, so I will try my level best to identify the basics of the techniques in these fields. And by the end of the presentation, you will have some clear idea of how the artificial intelligence, computer science, how the shaping the future of the healthcare. So these technologies used to as the doctor's assistants, but not the doctors. All right. Hope you all know the artificial intelligence. So artificial intelligence is the building intelligence into the machines. So when you compare the human intelligence, so human beings are the most intelligent. So if those kind of intelligence we can give to the machines, so then the building intelligence is machine we call the artificial intelligence. So human biological machines, the brain, are learning from the experience. So as similar to this, so normally artificial these machines are learning from the data. So these days we are having large good data sets, and we have good computers, GPUs. Then this process is very much easier. So when there are three types of artificial intelligence. So we are now facing the artificial narrow intelligence. Is the machine is capable of performing any specific task better than the human. So the basic example is the self-driving cars. So when come to 2040, the researchers assume that we can go for the artificial general intelligence. So means the complete human being can replace by the machine. When come to the 2060, we can go to the artificial super intelligence. So the machines surpass human intelligence in the all aspects. Right. This is what AI and how it works. So you may have seen, I think you may have seen this before, this graph, and you may have heard this before. So this is the building blocks of the artificial intelligence. So it's a set of algorithms and the commands. So there are two subsets of artificial intelligence, machine learning and deep learning algorithms. When you talk about the the machine learning is the some computational techniques and some mathematical models. So then machines can learn from the data, as I earlier said. So then machine can recognize the pattern from the data. So after that, the machine can make some predictions. So in the deep learning is another subset of machine learning. So then allowing more complicated patterns. So next, the main topic cover the computer vision. So it is a sub branch of the artificial intelligence, machine learning, and deep learning. So normally computer vision is train the computers to understand the visual world. You can see the human vision. This is normally our human vision system. Normally, people using eye and the brain to understand the real world. So as similar, so the computer vision system using high-tech cameras and computers and the machine learning, deep learning module to understand the visual world. So this is the basic idea of computer vision. Next, we move to the comparison of the human vision and the computer vision. So this is related to biomedical. So this is the human vision system. I already told the eye and the brain. So if the doctor look into the patient's body, and if the doctor can guess some kind of a skin cancers. So as similar, the computer vision system can also analyze this system. So within a very few seconds. So, but there is not as simple as it looks. It's need the trained machine learning and deep learning models. So that's why these technologies use doctors' assistants, not the doctors. So this is the computer vision in how the use in digital healthcare sector. So normally in the healthcare sector, we acquire some X-ray images, CT scans, MRIs. So these images. So what we are doing in these the computer vision, using computer vision techniques, we can extract useful informations. So using these computer vision techniques, then the doctors very much benefit to guess and analyze some difficult in cases. So doctors can get clear idea from these kind of informations. So these are some advantages with the computer vision. So it's a very enhanced accuracy. So when compared to the human vision and computer visions in the healthcare, so the humans can make mistakes. So with the very trained machine learning, deep learning model, so with a very good accuracy, so they can get a very good accurate answers. So early detection. So early detection is very much crucial when diseases like cancer. So if we can early detect using these kind of technologies, so it very much advantage. So it's speed and efficiency. So when if can give the quick decisions in healthcare, so making can save lives. So the remote diagnosis, mainly the systems like telemedicine, so the doctors can help to the rural area patients as well. So the cost effective the means, so not like early, we no need to go for the number of tests. So using one or two tests, we can get more information from using these computer vision techniques. And the personalized treatments. So the patients can and get their personalized treatment plan by using these some kind of apps in these computer vision systems. So, and the immersive learning experience, so in the medical students and those who are students in the medical sector, using the VR, AR interaction get much benefit. So I will describe these things in future slides also. So these are some famous libraries in the computer vision. So the OpenCV is very much popular in the image processing, so image and object detection, real-time creation, and the TensorFlow Keras. These are some advanced, the most popular deep learning models. So these techniques I going to describe in next slides. So there are some the famous libraries, the PyTorch, Skit Images, Philo, and the DLib, Matplotlib, Tesseract, MediaBug likewise. So these are the revolutions of computer vision with the deep learning. So you can see when we come to the latest with the data set, so gradually the error is decreasing, as well as when we look the network architecture. So now these days we are having with good accuracy network architectures. So these are some mathematical foundation with the computer visions. So normally when we working with the image and videos, so normally these images are made with some small pixels. So always we have to work with matrix. And we have to analyze these histograms and these pixel values. So linear algebra is basics, and we need to analyze the harmonic analysis. This means just like a Fourier transformation. So we need to from the time domain to frequency domains as well. And some applications we need to get some depth information. So for that we need more than one camera setup. For that, as well as we need to some 3D informations also. For these cases, we are using different geometries and different equations, calculation, and probability statistics also. So these are the techniques we are using in this healthcare sector. So object detection is the an important technology, one of the technology in healthcare sector. So the object detection is that involves identify the things within the image using some bounding box. All right. So using these using trained machine learning, deep learning model can train these using feature detections. So as example, so this is one well-trained deep learning model to analyze some fractures using some X-ray images, as well as some trained models to identify some viruses like COVID-19 using some medical images. And there are some brain tumor, the brain tumor identification using some brain images. So this is this one also very the main technology when we're using the computer visions. So this is to identify and categorize the objects within the image. So means using these for that they are using several image processing technique like color histogram, text analysis, and shape descriptors. So in there the technology is using some deep learning models. So the trained model can identify from the images whether is cancer or it's a non-cancer image. So next one is the image segmentation. So image segmentation is the beyond the object detection or as object classification. So in here normally we segmented and divide into some segmentation. So this is some brain tumor segmentation, and this is some segmentations of the organs. And the image registration also very important when we working with the in the healthcare sector. So if we have multiple images from same scene from different viewpoints, as means a different image types like CT and MRI. So we can align into a common coordinate systems. So from these technology, the doctors can get more informations. So the next one is the post detection. So it's a hot topics in these days. So in here, the computer identify some key points in human posture. So it means a machine can understand the human movements using these key points. So whether they can, the machines can understand what is the position, standing, sitting, likewise. So the post estimation is normally used the human robot interactions since past decade. The image reconstruction. So reconstruction is using some raw data. We can turn into a separate images or as 3D images. So doctors can easily understand these images rather than the normal basic images. So denoising is the removing noise from the existing images. So next one is data generation. So data generation involves creating new data using a trained mathematical, using some deep learning and machine learning model. So there are several techniques used in image processing, the data augmentations, so and general external networks likewise. So these are the important part of this presentation. So these are some applications using healthcare sector. So the computer vision is help to automating the prescription ordering as a application. So there are some good trained deep learning models. They can read the doctor's handwriting and prescription. So normally people can upload their doctor's prescriptions that apps. Then automatically the patients can order their medicines from their home. So next one is we have we talk about the object classification and the object detection. So these two techniques used in to detecting tumors and cancers in some mainly the skin. So there are some set of applications. So patients can get the pictures and analyze. There are some advanced deep learning models they can detect the early detection using using the camera. So the doctors can identify early detection of the skin cancers. So there are some advanced application that the detection of leukemia. So some of the researchers already developed some advanced deep learning models to identify early detection as well with some blood samples. So that next one is the surgical guidance. So though it is not much popular in Sri Lanka, so normally other countries were using the surgical guidance. So the surgeons during the surgical procedures by using very good camera system. So then the doctors can help and perform surgeries with more accurately. So there are some robo assist surgeries in other countries. So surgeons are normally, you can see, sitting a few feet away from the patients. So doctors are remotely they can control the arms, and the surgeons has to finger control. They can change these cameras. You can see. the surgeons are sitting on very comfortable chair. You can see their body was very comfortable, though they have very amazing view. Then 3D view also. There are, so these are the robots assisting surgery. So
tissue. Using manual technique, a surgeon applies a trans.
So next application is some cell counting applications. So in these days, there are a set of good trained models to identify and they can accurately count the cells using some medical samples. So the hospital safety application. So hospital safety application is very much crucial. So from using these computer vision techniques, so no need to monitor 24/7 surveillances. So using these force estimations and these surveillance monitoring, so she can get the monitor and real time alarm also. Not only these kind of safety, we can analyze, we can get the information, the fire and smoke detectors as well. So autonomous patient safety also very much very crucial in this healthcare sector. So the nurses no need to 24/7 care, and the computer vision using techniques. So the computer can analyze the patient, the falling, the risk of falling, and reducing the risk of some accidents as well. So these are some smart operation facilities. So doctors are three-dimensional real-time screening as well, and there are some instrumental detections also. So medical education is these are not much using in Sri Lanka. So basically other countries using the virtual reality, augmented reality, and mixed reality applications to train the medical students and the students in medical sector. So they can interact with the they no need to real body. Also they can they no need they can practice even injection also, you wearing this kind of virtual mixed reality device. So and the treatments of the patients. So in the rehabilitation process, the many countries, the mainly the diseases like dementia, the Alzheimer's. So the early stage of dementia patients using this kind of a rehabilitation, the most researchers found that there are some control of these kind of diseases where with using so interaction with these kind of virtual reality sets. So these are some future the healthcare research areas. The medical image analysis, then surgical assistant navigation, telemedicine and remote monitoring, rehabilitation, the AR applications, and fluorescent measuring and remote monitoring applications. So these are this is some famous American computer engineer, computer scientist. So he told that AI will not replace human, but human using AI will. So the AI not going to come and replace the human if the people don't use the AI, then human can replace. So thank you.